afternoon, everybody. I'm Daniele Ottaviani from CINECA. I'm the head of the Quantum Computing Lab. Today I will tell you something about our idea of integration of HPC and quantum computers. So if you are an expert in this topic, this talk will be very, very easy for you because I will try to give you our overview of a simple overview of what we want to do for integrating the quantum computers in, thank you, this in an HPC environment. What it means to integrate a quantum computer in a HPC environment, and then if we will have some time, I will also show you something about our work, what we do at CINECA. So first of all, what is CINECA? CINECA is the largest Italian supercomputing center. We are hosting entities for one of the European quantum computers that were selected in October 2022. And in the context of this section, we are going to integrate this new technology in our facility, in our data center. So everything starts with this paper here. What is this paper? It's from John Preskill. It was nominated a lot of times during this beautiful event. And John Preskill said that what can we do with the NISQ computer that we have right now? Right now, in this case, means 2018, so prehistorical time for the quantum computers in this occasion. And what we can do with this computer? One idea is to use them as accelerators for calculation. So like in the same way that we are using GPUs, we can imagine to use QPUs to accelerate the calculus. And what we can do with a quantum computer, for example, we can run big variational quantum eigensolvers or algorithms in general that are variational algorithms that uses classical resources to optimize parameters that can be used in a quantum computation in order to calculate something that can be used for example, in the field of quantum machine learning, or field of quantum chemistry, or in optimization. And another thing that is a little bit more advanced, but uses HPC in order to have a better quality of quantum computation is the error mitigation. So HPC can be used also for mitigate the error for the computation of our quantum computers. Okay, so how can we integrate a quantum computer into an HPC environment? Mostly we have three ways to integrate it. We have the standalone, we have the standalone way, let's say, that is, I have a quantum computer that is located in another room, in another state, in another place, and I can reach it using the internet. I have the co-located way that is the quantum computer is in the same room of the supercomputer, and I can use it and I can connect it to the supercomputer using an Ethernet cable or an InfiniBand or something like that. Or maybe the better way is to have a quantum computer directly inside the racks of my supercomputer. This is, of course, the best way. That is the thing that we are going to reach in the future. Right now, we have no technologies to do this kind of integration, and we are targeting the co-located one. So one of the first steps to integrate a quantum computer into an HPC environment is to co-locate the quantum computer in the same room of the supercomputer and connect it via a Ethernet or an InfiniBand cable. So this is the situation. I have this schematic quantum computer, supercomputer right here. These are the racks. Let's say that in this example, every rack is composed only by a node, and I have a quantum computer, and that I want to connect to my supercomputer. What I have to do? Okay, let's imagine something here we have to do. Integrating a quantum computer into an HPC environment is a task that can be very hard and very easy at the same time. I have also that. Perfect. Okay, so if we want to follow from the other screen, I can read it here. Okay, so in this case, the easy part is to connect it with an Ethernet cable. So I will connect my quantum computer to a node of my supercomputer, and I will use it simply using the node where it's connected. The hard part, for example, in this, for the hardware part of the installation of the quantum computer can be, for example, a better connection of the quantum computer to the node, because when I say that I'm connecting a quantum computer to a supercomputer, what I'm really saying is that I'm connecting not the QPU, but the classical control computer that is inside the quantum computer to the node of the supercomputer that I want to connect. So I'm connecting two classical computers in fact, okay? So what can I do to have better performances in this integration is, for example, to connect directly the classical supercomputer to the quantum processor, bypassing the classical interface computer that contains the firmware, the operating system, etc. Okay? So this is the advanced part, of course. For the point of view of the software part, for example, the beginner part, the easy part, is to use the computer only, the quantum computer only from the node that I selected to be the hosting node of the quantum computer. Okay, so in this case, I will use the SDK that is provided by the vendor of the quantum computer. I will use it directly from my node, and I will use the quantum computer as if it will be connected to a laptop, okay, to a completely independent computer. But what I really want to do is to use the quantum computer, with the other nodes of my supercomputer. What I want to do is to involve the quantum computer into a real HPC calculation. And this can be done using a little bit of using a particular software that can enable the calculation with HPC, with multiple nodes, with GPUs, and with QPUs. I have to obtain an SDK that can allow me and my users to call a quantum computer during the execution of a real HPC work that involved different nodes and not only the node that is linked to the quantum computer. And okay, so another thing that is very important to do is the scheduling, the middleware part. Because I don't know if you have experience, probably yes, using a supercomputer. Using a supercomputer is not the same thing to use a normal computer, okay? You cannot log into a supercomputer and use it like it will be your personal computer, or better, you can, but the administrators will send you at least a mail saying, what are you doing? What you have to do is to schedule your job, because a lot of people are using the same supercomputer as you, and you have to schedule and you have to say to the supercomputer, okay, I want to launch this job with 10 nodes using 4 GPUs, and the scheduler will launch for you the job when resources that you asked will be available, okay? And what we have to do in this case is to modify, the scheduler in order to find a way to ask to the scheduler to allocate the QPU for my job. In this example, for example, I'm asking to the supercomputer to allocate 10 nodes with 4 GPUs for each node and the QPU. Okay, this is of course something that is not existing right now. We will develop also this feature, but this is the idea that we have in mind to give to the user the possibility to allocate a QPU in a job. Okay, the same way that you are using a GPU. Another problem is the allocation, the efficient allocation. What is the efficient allocation? Efficient allocation means that we will integrate only 1 or 2 quantum computers in our facility, okay? And a quantum computer is a rare resource in this case, because we have with the Leonardo, our supercomputer, we have more than 10,000 GPUs, for example. So if you are using 1, 2, 3 GPUs, you will probably find in no time a node with a GPU that you can actually use. This is not the same thing for the quantum computer, because the quantum computer is only 1 or 2 at maximum No, not 10,000, surely. Okay, so if you want to use the quantum computer, you will have to wait. And you maybe have to wait a lot of time because, for example, a neutral atoms quantum computer is a computer that requires a certain amount of time to run, okay? So one thing that we can do to solve this problem is to study a way to use the quantum computer simultaneously from different users. We can leverage the fact that, for example, a neutral atom computer can be composed by a lot of qubits, and we will investigate a way to merge different jobs into a single job in order to give to the user the possibility to use the quantum computer simultaneously. Of course, this will not solve the problem, but it will be a start for solving the problem. Another thing is, for example, the fact that I was saying before that the quantum computers have different speeds, okay? They have the pros and cons. One of them is the speed of the quantum computer. For example, the neutral atom, sorry, it's a wrong button. Okay. The neutral atom can do a one-shot, psychedelic, cool. One shot for second, trapped ions 100 shots per second, and a superconducting 1000. So they have different. If I want to cache every single shot or something like that, I have to. Okay. So I have to be sure that I can use efficiently my other resources. For example, if I'm running a VQE with a supercomputer and neutral atoms quantum computer, and the quantum part is very slow, it's usually that I allocate 10 nodes of my supercomputer and tell them to wait for the end of the quantum computer. I will decide to free that resources. On the other hand, if I have a superconducting computer, what I have to do is to modify the scheduler because the shots are very, very fast, and I have to cache them using a better scheduler because right now we don't have the need to cache something so fast. Okay, so why I'm telling you that? Because we are one of the 6 hosting entities that will host a quantum computer in our facility, thanks to the EuroSPC Joint Undertaking program. And with us, we are here. We decided to integrate a neutral atom quantum computer because personally I think that they are very, very efficient, maybe for one of the best quantum computers, but we don't know that. Of course, it's only my impression. And France will integrate a photonic quantum computer. LumiQ in Finland, but in this particular project based in the Czech Republic, will integrate a superconducting computer, and the same thing for Germany. And here we have the superconducting Spanish quantum computer that will be a quantum annealer, and the Poland trapped ion. So the idea is to work together, okay? It's not very important what quantum computer we are going to integrate. The idea is to work together to give to the researchers, because we are supercomputing centers, and we are center of support for the research. So we want to give to our users the possibility to use all the quantum computers that we have right now, in order to ask them after a certain amount of time what are the best computer related to certain kind of algorithm, etc. Okay, so we want to give everything as possible to our users. In our case, for example, we have Leonardo. Leonardo is a supercomputer. Right now is the 6th most powerful supercomputer in the world. We are going, I think, for mid-2025, but also the end of 2035, we will see what we will do, because when the institution are involved, there is always a lot of delay, but we will integrate at least a 100 qubits neutral atoms quantum simulator, an analog quantum computer that will become, we hope, a digital quantum computer in the future. Besides that, we will also integrate a superconducting computer, a very small superconducting computer, just to integrate the, this is not part of the EuroSPC program, this is a CINECA initiative. We will also integrate a supercomputer, a little supercomputer in our facility. And this is possible also because Leonardo has a modular supercomputing architecture, was developed in a project called DEEP, and this architecture is very good for heterogeneous computing, because we understood that heterogeneous computing is the only way that we have to beat the extra, so to reach very interesting computing power for our supercomputers, because we know that only CPUs are not enough. We know that GPUs are good, but they are not enough too. We have to look for other systems in order to accelerate the computational power of our computer. Right now we are targeting the quantum computers, and maybe in the future something like a neuromorphic module. Why not? Okay, so two words about our quantum computing lab. What we do in CINECA is to give to our users the possibility to use quantum computers. What we do, we organize teaching, outreaching, and dissemination events every year for teach our users how to use a quantum computer. We are part of different European and national projects. One, for example, the HPC-QS project that is a collaboration between a lot of centers and entities in Europe to integrate simulators into an HPC environment. We are in this is the National Italian Supercomputing Center for Big Data, HPC, and Quantum Computing that will also give us more quantum computers in Italy, and we give to our users the quantum computing actual quantum computing resources. Right now, only in cloud. We have an agreement with DIV and Pascal, and maybe in the future with other, companies, of course. And we will use our supercomputers to emulate quantum computers to give also this possibility to our users. This is a list, if you want to do of the HPC emulators installed in Leonardo. If you look, every emulator that can be installed in this way is installed using GPUs, MPI, and QQuantum libraries for accelerating the emulation. We have also, this one in particular was developed by us in collaboration with the University of Padua, and is a tensor network emulator, and we are installing also other emulators during time. Okay, just to give you a quick overview of the environment, the Italian and the European environment. This way, so one of the targets of the National Center Initiative is to connect all the servers that are scattered in the Italian soil. Okay, we have a lot of different servers distributed in different little data centers in Italy. What you want to do is to connect them and to have a big supercomputing center all across Italy. This center will be enriched with quantum computers. The first one will be the one that we install in synergy with Leonardo, but also we will develop other 3 quantum computers, one in Rome, one in Florence, and one in Naples, based in photonic neutral atoms and superconducting technology. We are going to develop quantum computers thanks to this initiative. And also we have the University of Padua that will bring us another quantum computer, and maybe a trapped ions one, that will be also integrated in our environment. And this initiative, so this very nice and big environment that we are creating in Italy, will also be part of an initiative of a European level that will include the members of the EuroSPC initiative for the integration of quantum computers and HPC computer, and but also the HPC QS initially. So, as a matter of fact, at the end of as a result of this big program, our vision is to give to the user the possibility to use every single computer present in Italy and every single computer and quantum computer present in Europe, simply connecting to Leonardo or to another system in CINECA, and everything will be connected and you will able to use all the resources that you need to run your research. With that, I thank you for your attention and have a good continuation of the event. Thanks a lot.